brought to you by Thesis123.com. I learn and teach online.
Here is the next question, number 30. Consider the following asymptotic body magnitude plot. Omega is in radians per second. Which one of the following transfer functions is best represented by the above body magnitude plot? Okay, so we have been given the magnitude plot, body magnitude plot, and we have been asked which of the four options is the right transfer function. Okay, so it is usually the other way around. We would be given a transfer function and asked to plot the body plot, but then here a twist. Okay, so before we get into how to identify which one of the four options is the right option, let's go into what a body plot actually is. So a body plot is the frequency response of a transfer function where one plot is the magnitude versus the logarithm and the other is the phase angle. So usually for a certain frequency we would have to determine both the magnitude as well as phase angle. But in this plot we have been given only the magnitude. Okay, so let me just write that down for you. Frequency response of a transfer function. Okay, so usually body plots can be drawn for both open loop as well as for closed loop systems, most commonly for open loop systems. And the standard form of what you need to remember or for the transfer function is that it would be in the form of 1 plus ST1. You will notice that in the denominator all of these forms support. You have 1 plus ST1 multiplied by 1 plus ST2 and so on and so forth. You will find this form in the denominator. So we see that all the options have this form of denominator. So using the plot, let's try to find out which one is right. Now you will see here that we have a linear line here as well as a linear line here. Now these two are the slopes. Now the value given of this slope here is 20 decibels by decade, and this one is minus 40 decibels by decade. And another point that you will have to remember is that for a body magnitude plot, the slope the value usually starts from 20. It means that if there is a square in the term, if there is a square anywhere, either in the numerator or in the denominator, you will have to multiply it by the value 20. In the numerator, okay, here are some of the rules that you will have to remember, okay. So I'll put down the rule for the numerator as well as the denominator. The positive slope is always for the numerator, negative slope for the denominator. That actually helps, right? So we have the slope is positive for the numerator, and it always starts at 20. If there was a square term in the numerator, then it would be 2 times 20. So 2 times 20 is 40. So since the value here is 20, that means that we have a single term in the numerator which doesn't have a power. It's not raised to the power of 2 or so and so forth. Okay, so it starts with the value 20 decibels per decade. Okay, so this is the slope for the numerator. For the denominator, slope is negative for the denominator, and again you will have to think about the power of the factors over here. So the first factor doesn't have a power, it is single, so the value would be 20, but for the second one it is times 2, which means that minus 20 times 2, which is minus 40. So this actually helps. Then you know that we can rule out option C and we can rule out option B, because it says minus 40, which means that it is minus 20 into 2. Minus 20 into 2. So that tells us that there is a squared term in the denominator, which means it can either be A or it can be D, one of these two. So that is clear. Now the next thing we need to know is, if you observe, here we have 0.5s, 0.25s, 2s and 4s. Quite a difference. Whole numbers, decimal numbers. So in order to check that, we can look at the frequencies over here. Now I have drawn I have put down 2 points over here, omega L and omega H. Omega L and omega H are known as corner frequencies. And the point at which the first slope comes at, 0.5 and 0.8, are supposed to be the frequencies at either ends. So the corner frequency will always be, the lower frequency will always be greater than the point given here on the plot, and omega H, or the second corner frequency, would be lesser than the point on the other side. So this is the general rule. Okay. So, and omega L and omega H usually have the form 1 plus S by omega. 1 plus S by omega. If you remember this form, it will be quite useful, because once you know 1 plus S by omega, that is 1 by omega times S. So here if it is omega H is clearly lesser than 8. So take any value, just for an example, just to rule out which option could be wrong. So let's take that omega H is, say, 5. So that's 1 by 5. 1 by 5 is a decimal number. So all in all, we see that option A satisfies all of these rules and conditions. We have a square term which determines that, which shows that this slope over here is negative and it is times 40. And we also see that since omega H is lesser than 8, it has to be somewhere, lesser than 8. Any value, you can take either 4 or 5 or 6 and determine it. And once you have that value, and because it is a negative slope, the form would be 1 plus S by omega. So 1 by omega, say for example 1 by 5 or 1 by 4, either way the value is a decimal value. So 1 by 4 will give us 0.25, which means that omega H is 4, and A would be the right option. I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.